Hey everybody, welcome to video 16-2. This is arc length that we're talking about in this time. I'm on page 863 with you, and we're going to start with the Explore for once. So an arc is an unbroken part of a circle, as we see here. We already know that if we are measuring it, it's in degrees, but specifically if we're talking arc length, that's like if we're taking this little tiny piece of the circle and stretching it out flat and then putting it up against a ruler. Okay, so it's the distance, if it were a straight line in like feet or centimeters or whatever units that we're using to express the circle in terms of the radius. And we can use proportional reasoning, as we're seeing here, to find the arc length. So again, measure is not the same as length. That's really important to get. Measure is measured in degrees, and then length is going to be measured in linear units, so centimeters, feet, millimeters, whatever. So the first thing we're going to do here as we're deriving the formula or coming up with the formula for arc length is, if we realize that the arc length is part of the bigger circumference, then it would be good to know what is the whole circumference. So good thing we just watched that video and you already know that formula is C equals 2 pi r. So in this case, as we're looking at this diagram here in the Explore, our radius is 9 centimeters, so we're going to substitute 9 in there, and we should get that circumference is 18 pi. Now, two different ways are going to be asked to give your answers in this section. It's called in terms of pi. So I want you to know that that means, you guys, that there are no nasty decimals in my answer, okay? I am going to keep the pi symbol. That's the pi symbol in my answer. And I'm basically just going to simplify everything around the pi symbol, but leave the pi in it, okay? So again, no decimals, keep the pi symbol in your answer, and then just simply simplify everything else around the pi symbol, keeping it there as long as possible. So our circumference is 18 pi. So now let's go to part B. If the entire circle we know has 360 degrees in it total, then the arc length is going to be 60 out of 360, or 1/6 of the circumference. It's a proportion of the circumference. So we're going to fill in the blanks now to find the arc length. 1/6 of the circumference we know is 18 pi that we just found. Multiply 1/6 times 18, and we get 3 pi. And then we're going to use a calculator to evaluate. In this case, we're actually using the pi key, which is the second function button, and then your caret key right above the operator keys, meaning add, subtract, multiply, divide, operator keys is the caret. So if we do second function and then the caret key, that's going to paste a pi symbol in there. And that is the many digits that the pi symbol has in the calculator's memory is getting used there. So it's a lot more accurate than just 3.14. So you're going to use the calculator to evaluate here, and we get that it is approximately 3 times that pi is approximately 9.4248. Remember, we'll go out to more decimal places than we need, and then we round. And back at the beginning of the problem, we were rounding to the nearest tenth. So in this case, it's going to be either exactly 3 pi or 9.4. And then remember, the units is whatever the units was in the beginning of the problem, which is centimeters. So it's a linear length. Remember, we don't need to do any area, so we don't need to do centimeters squared. We're just talking about how long is the arc, and so it's 9.4 centimeters. So I want you to see on what you guys can do here. with applying this formula, and we have a general formula that says the arc length S is going to always be equal to the measure of the arc, this is in degrees, out of 360. So there's the fraction of the circumference 2 pi r. So in example 1, we have a clock face and we want to know how far does the tip of the minute hand reaches all the way out to the edge of the clock, so we're going to assume that that's the same thing as the radius. How long does that tip travel as we go from 12 to 12:15? So that is 90 degrees, right? 90 out of 360, or basically a quarter of the circumference. So here's 90 out of 360 times 2 pi, and then the radius we're told is 10 inches in the beginning of that problem. So then we get, if we simplify all of this together, 90 times 2 times 10, divide by 360, we get 5 pi in terms of pi, remember, and then round that to the nearest tenth, as it says, and we'll put in our pi key. 5 times pi, we get 15.7, and that is just linear units, so in inches. Now let's see what we can do with part B. Still talking about a clock here. The minute hand now is 6 inches long, as we see, and to the nearest tenth of an inch we want to know how far does the tip of the minute hand travel if we go all the way from 12 to 12:30. So we're moving 30 minutes out of 60, which is the same thing as 1/2. So the central angle is half of 360, or 180 degrees. And so here's my formula. Arc length S is equal to the measure out of 360 times the circumference, 2 pi r. And we know that measure we just found for half of the circle is 180. So we're basically doing half of 2 pi r when r is 6. And so that's half of 12 pi, or 6 pi. And that is, using my calculator, 18.8 inches long. So that's my answer. On the next page, you guys, here we're going to do another arc length problem with our your turn number 3. This time the minute hand is 8 inches long, and I want to know how far are we rotating if we go all the way from noon to 12:45. So express that as a number of degrees out of 360, and then use the radius and see how far that minute hand is going to travel. And I'll see you tomorrow.